and good afternoon, and thank you for waiting. So we are going to run this kind of panel or questions and answer session. So now we will have chance to ask your questions because we were a bit pressed with the time when we are having the presentations earlier. And we can try to discuss a bit more in details our views on immersive media, immersive visual technologies, what are the research challenges or next research steps. So maybe I will start with one or two questions, and then we can get also some questions from the audience before we close the official part of the event. So, for example, when we speak about immersive technologies and immersiveness, now it goes to these two things which were emphasized today, like realism and then interactivity. And these two things, they are achieved in different ways. So realism is related with resolution or high dynamic range or 3D. My question is, in your view, what is the most important modality or effect which should be delivered in order to achieve this, this effect of immersiveness? Like next step, like how the technology should be steered in the way?
So in my view, both, what you concretely mentioned. So the visual quality, that's out of the question, that should be there. So the real problem that's still, as of today, we do not have the ultimate display. So there is still a way to go until we really have in large scale, good resolution, high field of depth, and then all of these parameters. And then don't forget, so the real challenge that to step from 2D or stereo to a real immersive 3D, it's maybe 3 orders of magnitudes of data, and then this is not only data, but physically you should have the hardware and pixels there. Of course, then it depends on the application, whether you, what kind of interactivity you apply. So in many cases, of course, if you build up a kind of holodeck experience, then it should work like in the reality. So your tactile feedback should be there. The object should move according to your movement, whatever. So some way we try to mimic the reality. So summarizing, you need the quality, visual quality, of course, because I'm a display guy. So I'm starting with this. And depending on the application, you really have to approach those kind of interactive feedback and interaction devices that really makes you a kind of mixed reality. So that's what I feel.
I guess my comment would be it's very dependent on the application. I'm not sure there's one answer. Just thinking of some applications, I guess for cinema, I would think actually temporal resolutions, a high frame rate is an obvious thing to improve because it's very low at the moment, and it's important for action films where things are happening fast, and for those very wide screens where when something moves from one side of the screen to the other, it can be going across, 90 degrees in your visual field.
In jumps from one picture to the next, if you see the first movement, you see the positions where the object has stayed in between.
Yeah, exactly. So it looks very choppy. You can see it's not real. It doesn't look like a real object moving.
Yes.
And I think we kind of forget how unnatural it looks because we're used to seeing cinema and kind of forgiving it. But if you want to reproduce reality, I think frame rate is critical. The other thing that springs to mind, actually, and I'm embarrassed that it isn't sort of 3D, but is the luminance and the dynamic range. So we talked a bit about high dynamic range in the context of photography, but having displays that can represent a very wide range of luminances is going to be important in terms of cinema and so on. I think for 3D, the applications where that's maybe most important are sort of single viewer, where you can get the geometry completely right, so you can really have the illusion that there's something sitting on your desk and it's perfectly correct for you. Yeah, and then I guess also accommodation, as mentioned in my talk, is going to be critical, because without having the ability to represent accommodation correctly, as in your displays,
Yes.
you can't ever have really big disparities. And in the real world, there are huge disparities. You know, as I look at this desk to the back of the auditorium, it's an enormous difference. And there are all sorts of non-fusible disparities that would appear double, except that they're blurred, and my visual system therefore discounts them. But if they're not blurred, if they appear sharp, then that doesn't work. So then you can blur them in software, but then you have to know where the person is looking. So that all gets a bit complicated. Anyway, so those would be some of my thoughts.
I think there is another point that, especially for the Raytrix cameras, it's not about appearance and a subjective impression, but more about precision and accuracy, because for industrial inspection, it's not interesting that it looks fancy or it's correctly illuminated, but that there are precise metric values that can be measured. And this is a complete different task. So it's not only the application in cinema or for posters, but also for the application area, if it's the impression, the feeling that should be aimed at or a measuring tool.
Okay, I'll ask one more question. Yeah, let's Kari comment.
So for immersiveness, I think motion parallax is still my number one. And that's there's two components there. One is the latency, just being able to measure it and reflect that with a display. But that's fairly easy to deal with, and especially if you have synthetic content, like if you have 3D model that you're rendering with graphics system, that's doable. But then now that you have this, like Nokia's Ozo camera and John's similar camera and all of the other rigs, as you really want to capture this real experiences, real situations. But they are typically just panoramas. They might be stereoscopic panoramas, but they don't allow you to kind of move your head, and then you don't get the motion parallax. And I think motion parallax is even bigger component than stereopsis or accommodation. Like most people think that you really need two eyes to be able to see in 3D, but that's not true. Like, it's close one of your eyes and then move your head a little bit, then you will notice that you did not become 3D blind.
Okay, actually, this was, I was going to ask the next question, which would be your already answer. Which is the modality which you think is most important? So for you, it's motion parallax. Jenny mentioned high dynamic range. So then, yeah.
I totally agree with you, Kari, on motion parallax for some applications. So if I've got something on my desk and I want to be able to move around it, then it's very, very important, I think. I guess I've done some work on television and cinema, so maybe those applications are higher in my mind. And there, it's kind of harder to see how that would work. I mean, for a start, in cinema, I'm not moving my head very much typically, but also I don't necessarily want to get a different view depending where I'm sitting. Do you know what I mean? If I'm on the end of a row, I'm going to be looking at everyone from the side. So
with motion parallax, you don't get the view is not that different. I mean, you're not going to turn like 90 degrees and look the person from the side. It's just that you get the nearby objects kind of move more than further away objects. So it gives you the perception of depth. You kind of figure out like what's nearby, what's further away. And if the question is about immersion, so then that really it's the immersion part is like, does the scene or whatever I see, does it react to what I feel in my proprioception and all of that? So that's kind of the reason I gave that.
I would just add something, because I strongly agree. So imagine for the motion parallax, it means that sometimes you have your micro movements. You even do not recognize, but if you would like to see how is that and locate something, you immediately move more than your eye baseline. And then if this is missing, from a 3D content, and the 3D content always rotates and follows you because the information is not there, you will feel it unnatural. And then maybe one sentence here. So all of those stuff, I mean, high dynamic range, nice color gamut, these are all important, but let's make it clear. These are the 2D characteristic of an image. Of course, for a 3D, this is necessary. So if I would build a display in some years, 3D display, that will be at the same time high dynamic range as well. Because as of my philosophy, we would like to give you back the same natural view what you see. And this is a high dynamic range view, very good color gamut, but very good resolution, what you see. So all of those are important, but the typical 3D stuff is like the angular resolution, motion parallax, the field of view where your display is there. So these are the typical 3D measures of X.
Okay, question from the audience?
I would like to point another big issue. As we go like toward immersiveness, we deal with big data, much more big data. I think the compression is behind the emerging new type of data, like the 360, and like in the augmented virtual reality, we have data from different sources.
Basically, the question is, if we want to achieve, for example, motion parallax, what would be the data representation? And okay, just to widen the question, do we need really a kind of unified representation, or it will be again application specific? Like we have 3D models, and it is like very nice with computer graphic tools to handle. But then we have real images, and we have either to take very dense set of images or have to have computational methods to reconstruct the missing stuff. And this would go either by reconstructing the geometry or by doing something purely image-based. So which path? Okay.
I think there are different solutions for different kinds of areas. If you have a very restricted area of viewer position and you don't need much parallax, so you have a restricted set of views, you can easily do it with a live rendering of the 3D model. If you have a large viewing angle and want to have parallax in loads of different views, then you have such huge amounts of data that you can't render it in the same time.
Yeah, but doesn't it too much ad hoc? Like for each application, you have to build your own data and your own data representation. And then how you repurpose, for example.
Well, if you have first a live content situation, for example, and have a restricted viewing area and use just the 3D model to make live pictures, then you can reuse that 3D model to convert and render other data formats that maybe represent the pitch of the lenses and the amount of viewing angles you store behind each lens.
So you are in favor of 3D model, 3D scene reconstruction, and then using the model then for whatever purposes?
I think you will have to go both ways, and perhaps it also is a decision which is made by the progress of our hardware. If we are able to push huge amounts of data through lines, then we can render it once and then distribute it to everybody who wants to see it. If it's not possible to have that data rate, we must reduce it to the last meter to the display and just transport the 3D model to where it is seen. And then the parameterized 3D model can make a video and you will live render the content on each display.
Okay. Yeah.
To go back to the good old times, I think it's a same problem as in 2D, where we have different compression algorithms for the images and movies, even though if they are based on the same perception model, the application is different. So for the JPEG, for example, we have the still image, and there's another focus then on the MPEG for movie creation, where we use block matching and moving blocks to trick the eye. And I think similar things have to be done for 3D content, that the perception system has to be viewed in 3D and not in 2D. And I think there's a lot of research to do to find out how to trick the brain in 3D and not only in 2D.
I was thinking I couldn't contribute anything to this bit, but with the talk of brains, I can a little bit. So you can definitely take advantage of some of the properties of stereo vision, such as its pretty poor resolution compared to luminance. And I think that's known within the industry, but one other aspect that doesn't seem to be taken account very much is that actually we have different resolution for vertical edges as for horizontal. So we're much more sensitive to the horizontal edges than to the vertical. So potentially you could take that sort of information into account when designing your compression algorithm.
So I don't think we need 3D representation. So 3D representation is needed if you change the viewpoint radically. But if you only need to change it a little bit just to create the different views to left and right eye or the motion parallax, you don't need any 3D. Well, you need a little bit. You need like 2.5D, which is basically you just need to figure out which one is front and which one is back, and how much parallax you're going to get, how much disparity when you switch from left eye to right eye or move your head. And like, what's your Arne? Arne said, kind of implied, I think the solution is combined in the compression, because in the if you think of the video compression, you have lots of redundancy. The previous frame usually looks very much like the next frame, and then if you have the motion vectors, then you can predict the majority of the pixels from the previous frame, and then you just need to kind of do the add the errors of your prediction, and that's how you compress video. Well, you can do the same thing if you have like omnidirectional stereo or multi-baseline stereo. Like the best prediction is like you know the geometry of the cameras, then you know the epipolar lines, you know where the correspondences are going to be. And then the only uncertainty is like how far along the epipolar line do you go. So that's now, it becomes simpler than in video. In video you need 2D vectors. For the motion. In stereo, you only need 1D. You just need the length or the disparity. So that basically would be the thing that you would use, A, for figuring out the disparities if you switch between the eyes or the motion parallax, and B, for correspondence and the compression. So it would be a unified solution. It would be 2.5D solution. You can infer the depth from the disparity too, but you don't really need it.
Okay. So the problem I see with standard 2D as compression and then using disparities is that I've tried to use JPEG compressed images for stereo reconstruction. And there is a certain limit that when you use a compression factor of 0 or a quality factor of 0.7, there's somewhere a break point where you have quite good reconstruction in 3D, but then there's this point where it breaks down and your output is totally trashed. So there's a certain limit to compressing the 2D information. And so I think the I want to go into the direction that we should find out how we can cheat the brain in 3D, that we know which part is unnecessary, even though we have to record it in 3D, but what we can throw away afterwards because the brain is not fast enough. Or some problem we have in the cinema 3D films is that I get totally crazy when these fast action scenes are cutted in the same way they're in 2D action movies, maybe in the 90s or whatever, where we have very fast cuts, and when you do this in 3D, you will get sick within minutes or maybe a quarter hour, but you can't stand this for 3 hours. So I think this is something you have to focus on. We have to focus on.
Yeah. Okay, any other questions from the audience? Please.
Hello. As 2016 is kind of being hailed as the rebirth of VR, we can't ignore the newspapers and the magazines claiming excessive figures of Oculus Rift delivering 5 million headsets in 2016. I just want to know your opinion of what you think by, I mean, we've had revolutions before in kind of visual and in kind of general media, from the radio to television to color television. How do you think this will impact kind of your work and the world around us with this kind of mainstream now effect, or should we say the mainstream interest in VR and 3D?
Okay.
So Ville-Veikko Mattila from Nokia, he showed this kind of expectation of the kind of content that you can expect with this new displays, and I would think that if you start going from there, that at least give you a partial answer. I think the biggest part was games. So that's the easiest in the sense that the content is computer modeled and generated, and you can have these arbitrary viewpoints. And also the control problem is kind of solved. The gamers already know how to use the game controllers without looking at them. So you don't have to kind of find new ways of interacting. And you don't have to kind of move around, like gamers are happy to sit around and play. Then the next one would be sports. And the third one was porn. And then there were a couple of others, I forget what they were, but I think they're movies afterwards. But the movies has the problem that now, as was briefly mentioned, the directors actually have to learn the new medium. And it's quite different game of directing an omnidirectional movie than traditional kind of look via window kind of movie.
Okay. Any? If you, yeah.
Maybe I can have also a comment partly related to my presentation. So my experience was that any hype in the industry was beneficial to all of the related companies. So when I remember when the glasses 3D started, even if we thought from the beginning this is not a 3D and then it will go down, what happened, but it generated so much interest and then generated the critical mass who were dealing with, at that time, stereo 3D. But from that already it came out the multi-view stuff and similar happenings are going here with the VR systems. As I mentioned, it became evident that the same data set, which is basically, it was a kind of 2D legacy, is not anymore sufficient. And this is good to everyone. So this is good for the light field, because now it will be a kind of break. Then, okay, let's give up the old standards, the old infrastructure. Let's go for new standards and new possibilities, whatever we do. And on the long term, what I see, and then my philosophy is that if you create a virtual world, it should be limitless. So the most devices you have, so you have to wear goofy glass, whatever, I don't know, positioning marks. This is not the way to go. So the final stage will be that you see a glasses-free, perfect 3D. You will be tracked if needed. The system will react, and then the same immersion effect will be there for a collaborative and social scenario, and not just for one single person. So this is a kind of kid sickness and early stage stuff. A lot of money will go there, and let's discuss this in 3-4 years later, what will be the situation then.
Okay. I think Frederick had a question.
Thank you. My question is related to the threat of cyber sickness. So you have said that there's a growing immersiveness in the content, which is appreciated. However, one can conclude maybe that the risk of cyber sickness is also growing then, the more you are immersed into the content, maybe, it's just an hypothesis. And also related to this gaming industry, in fact, if you're playing a 3D ego shooter, your movements with the mouse or so on, they are so fast that might be an unnatural motion, yes, of your avatar. So what do you think, what could be some remedies in order to avoid, let's say, cyber sickness, which would impair the end result at the end of the day?
Thank you.
A short answer: to shut down the net for a day.
Yep.
Yeah, I think that's a very real problem, actually. And as the displays get better and better, then sickness becomes more of a problem. And I think you see that with the change from 2D to 3D. As I said a bit in my talk, I think it's not fully understood why that occurs. But I think the best guess out there is this Q conflict idea. But there I think it's interesting because actually, of course, 2D displays have massive Q conflict as well. You know, you're watching a 2D movie and the camera's zooming around, but you're not. So I think we must just have got used to that. That we have all obviously grown up watching television and so on, and our brains just sort of discount that conflict as not a problem, whereas a conflict that is kind of unexpected, I guess, may indicate that you've eaten some poisonous plant or something, and that's why you feel sick. I mean, that's the assumption about why our response to these Q conflicts is nausea as opposed to anything else. So, hypothetically, as people grow up with more experience of VR and 3D displays, one would expect them to report less of these kind of cyber sickness. And I think that's kind of the best hope, really. I'd also point out, and I always think it's intriguing when you think about just how good the brain is at sorting things out. So I think a lot of future technology is going to depend on chucking something that's vaguely sort of right at the brain and figuring out, and relying on the brain to figure everything out. So one example is brain-machine interfaces. Probably, I mean, it's a totally different area, but you know this sort of thing where you have electrodes on the scalp and you have to move the robot arm. And it's all based on models of motor cortex and so on, but these are incredibly crude, and you're picking up incredibly crude activity, and yet the brain learns the right mapping. You know, if I want the arm to move to the right, I have to kind of think like this. And that's why they can work to the extent that they do. So pictures kind of work like that as well. If you have a 2D picture, the image on your retina is actually geometrically completely wrong if you're viewing from any position other than the centre of projection from the camera that took it, and yet we're typically not aware of that. The brain just automatically corrects for that viewing position, which is kind of amazing. So that's the kind of power that the brain has and the sort of strength it can bring to bear on these problems. So maybe as people grow up becoming, as I say, used to VR in the same way that we're all used to 2D media, maybe our own brains will solve the problems and we won't have to rely on technology.
Okay.
Just short. So I think it's a matter of content also, because in the early times of these 3D shooters, as you mentioned, it was tried to bring the motion, the stepping of the person into the view. So the view goes this way all the time, and the people got sick, so they canceled this. No 3D shooter would now bring this waving movement in, because you'll get sick within a minute. So I think you have to adopt the content, and you have to try to get rid of this interference with the accelerometers and turn rate measurement and all this stuff that is within the brain and that cannot be brought in the right connection to the image you see.
Okay.
Yeah, so part of the solution, I think, is to get the latency low and get those gyros and accelerometers kind of working fast enough so that you don't get the discrepancy. Like you have your own gyro between the ears in the inner ear. So if the visual contact is in discord with that information, that's when you get sick. But there's also like other kinds of like slower ways of getting sick that has come with media, and it's, for example, nowadays almost everybody needs glasses, and like 100 years ago that was not the case. And why is that? So it's basically like people are reading so much, and that will actually screw up your vision with the children. And well, actually, new displays could be a solution for that too. Like if you would actually do your reading from a wearable display like Oculus Rift or something, and you have the optics there that allow you to kind of focus into infinity rather than focusing like half a meter away. Well, that would be really good for people not needing to have glasses.
Okay, thank you. Any other questions from the audience? Maybe one final question from me, and this would be name, okay, maybe two biggest challenges, research challenges, which have to be solved according to you, like in order to kind of achieve a breakthrough or to get a disruption. Something that it is challenging, not this type of incremental research. If it is very difficult, you can name one.
Okay, I already named mine. It's the very good motion parallax for captured content, not computer-generated content.
Yeah, but you told that it was easy, 2.5D, and that it's fine. So it is a small disparity, nothing.
Well, so that it actually works every time and doesn't break.
In my view, what I see, so no one thinks that so 3D is challenging in large scale, because all systems are scaling, or eye baseline. So if I make a wall-size display and you are standing 20 meters of that wall, that's almost mission impossible to do it. So in the sense, the challenge for me to increase the pixel density of the display is to be able to make large scale and high def display. And what I foresee here, that just in contrast what we are doing as of today, on the long term, the time multiplexing, that will be the leading technology. As of today, this is not available. So if you would like to buy a 3D display in 5 years' time, go for the spatial multiplex type product. So what Holografika is doing in the background, we have the so-called there is no name for it, it's like Super HoloVisio or whatever, so we are making the combination. So we combine either the multiple modular structure of the system, but each element will act as with a factor again based on time multiplexing. So to increase the display capacity without making it more expensive and so on. That is a challenge because there are no fast live wolf technologies available. I was discussing this with Philip as well. So that's the problem. This is in the material science and many ways. So if you know fast light wolf technology, then call immediately the 3D display guys.
So that was a challenging question, Atanas. So I think I've got two answers, one of which is a bit incremental, I agree, and one of which is probably impossible. So if you kind of titrate between them, you should work out. So the incremental one is, I guess, just what we've kind of said before, really, what I've said before, that I think it has to be glasses-free 3D, really, to be popular. People don't want to put on glasses. And, you know, gamers may put on VR headsets, but yeah, I think it's going to limit the take-up, certainly for entertainment purposes anyway. So glasses-free, and it has to be capable of, without compromising the resolution, so you don't want to have any screen door effects or everything. You want to have the beautiful high spatial resolution, and ideally also the accommodation queue so that you can have big disparities without having to worry about that. So that's a bit incremental. And then, but yeah, if you could just think totally outside the box and not be constrained by physics, then I guess what would be nice would be the ability to sort of have specify light to come from particular points in space, because then you really could have the sort of augmented reality. You know, I'll just have a little hologram, as in the Princess Leia kind of thing, sitting on that desk right there, and anyone can view it from any angle without glasses, and it'll all be optically correct. But I have no idea how that could be done.
We are working on the light already that makes a turn in the free space.
That would be good. Yeah, I think that would do.
That would be breakthrough. The mid-air projection without projection media. My wish would look like having terabytes per second of data rate without heat problems.
Okay.
Related to the Oculus Rift and such virtual reality devices, I think unsolved problem is controlling the movement in this environment, because there's no intuitive way to maneuver through such 3D environments. I have my keys and my mouse maybe, but an augmented reality glove or whatever, but yeah, it's no intuitive feeling of moving through this virtual reality world.
Okay. So, any other comments or final questions? So if not, you heard the next 5 challenges, so it's now your turn to start solving those problems. I wish to thank our presenters today. It was a very exciting industrial day of the workshop. I think very nice presentations, very kind of illuminating, presenting the problems and the state of the art from different points of view. So I would like to really thank the presenters very much.